This is the study of complex fractions and rates. So let's look at our number routine. Paul says 4 apples for $1 is a better buy, while Jerry says 25 apples for $6 is a better buy. Justify who is right. So we need to do it literally an apple-to-apple comparison. So what happens if each person buys 1 apple? So let's look at Paul. $1 for 4 apples. If he just wants to buy 1 apple, how do I break it down from 4 apples to 1 apple? I divide the numerator and denominator by 4. So I divide the numerator and denominator by 4. So what is $1 divided into 4 parts or 4 groups? That's 25 cents. So Paul pays 25 cents for 1 apple, 25 cents for each apple, or 25 cents per apple. They all mean the same thing. Jerry, on the other hand, pays $6 for 25 apples. What if he only wants to buy 1 apple? So I have to divide by 25 the numerator and denominator. So what is 6 divided by 25? Well, let's see. Can 25 go into 6? 0 times. So I need to divide this without changing the value of 6. So I add a 0.0. Can 25 go in 60? 2 times, which is 50. 60 minus 50 is 10. I bring down, add another 0, bring it down. How many 25s go in 100? 4 times. So this is 24 cents for each apple. 25 cents per apple, 25 cents for 1 apple. So Jerry is definitely a better buy. So that is definitely a better buy. So let's look at our next example. Alright, so in this one, after 4 hours, Pasha had traveled 217 miles. If she travels at a constant speed, how far will she have traveled after 1 hour? So they want you to break it down into 1 hour. So for those who like the bar model, here's an example of the bar model. So this whole bar represents 217 miles. I need to break it down into 4 sections. Each section will represent an hour. So how many miles will go to each hour? So let's divide this. 217 divided by 4. Can 4 go into 2? No. Can 4 go into 21? 5 times. So if you subtract that, you get 1. I bring down the 7. Can 4 go in 17? 4 times, which is 16. And I have 1 left over. I need to get rid of this remainder. Again, how do you get rid of the remainder? You add a 0.0 because it doesn't change the value of 217. So I bring it down. How many 4 is going to 10? 2 times. Don't forget a decimal point here. I hope this eventually stops. 10 minus 8 is 2. I have another 0. Bring it down. Can 4 go in 20? 5 times. Oh, it's done. So she can drive. She travels 54 1/4, 54 1/4, 54 25 mile each hour. If you want to figure out how much she travels in 2 hours, we could say 54 25 plus 54 25 is 108 50 for 2 hours. That's one way to do it. This is the BARD model. Some of you may say, I prefer a different one. So let's see this way. This is a proportional way. Can 4 hours be broken down into 1 hour? How do you break 4 hours into 1 hour? you divide by 4. So you need to divide the numerator and the denominator by 4. So 217 divided by 4, we did the work already here, is 54 and 25 hundredths mile for 1 hour. Per hour, each hour. So Rhoda is making meatballs for dinner. Her recipe calls for 1 pound of ground beef. At HEB, Rhoda finds 1.4 pound package of ground beef for $2.80. How much will 1 pound of ground beef cost? Because she only needs a pound, so maybe she'll go to the butcher and say, I just need 1 pound. I do not need these extra thing. So what should she do? So she'll tear open the package, and now she needs to figure out the cost. All right, so let me move the meat over here, and let's do the math. Well, I know. Let's use number sense. We know if she's buying less, only 1 pound, the price will be less. Can we assume on that one? We know our answer will be less than $2.80. So 1.4 pounds will cost $2.80. So if you buy 1 pound, we know it's going to be less. So if she buys 0.7 pound, which is half of it, then it's $1.40. So we know our answer will be between $1.40 and $2.80. So if I had to estimate, I haven't done any math yet, if I had to estimate maybe 210, 220, because it's between. So I think that's going to be, if I had to estimate. So we could set it up as a rate problem. It's $2.80 for how many pounds? 1 4/10 pounds of ground beef. But I only want to buy Rhoda only wants to buy 1 pound of ground beef. So how is she going to break it down for 1 4/10 pounds to 1 pound? Well, let me use my Calligraphy pen. I'll use blue. To break it down for 1.4 to 1 pound, to break it down, I have to divide by 1 4/10. Because what is 1.4 divided by 1.4? 1. So I need to divide the numerator and denominator by 1.4. So what is 2.80 divided by 1.4? If you forgot how to divide decimals, please go back to the subsequent lesson, the previous lessons, and see which one it is, how to divide it. So let's see. So I rewrite it as in fraction form, in case you forgot how to divide decimals. I don't know about you, but I need to turn this denominator or divisor into a whole number. So I need to multiply by 10. If I multiply it by 10, then the 1.4 will become 14. Some of you may have just do this. You just move the decimal 1 over. You move this decimal 1 over. So that'll be 28.0. Oh, wait. I know I can do that in my head. Can 24 even go to 28? How many 14s go into 28? 2. Exactly 2. Oh, the answer is $2. So 1 pound of ground beef will cost you $2. 1.4 pounds will cost you $2.80. So remember, I was doing my number sense. I knew it was going to be between $1.40 and around $2.80. So I had to guess. I'll say about $2.10. So you know what? I did actually a pretty good number sense right there, without taking out a calculator or without any math. So again, how did I do that? So I have 1.4 pounds. I need to break it down to a pound. And so in other words, I need to divide. So 280 divided by 1.4. As you can see, I rewrote it as a fraction. Again, I do not like working with decimals when I divide. So I had turned the 1.4 into a whole number by moving the decimal 1 over. So I moved this 1 over. So 28 divided by 14 is 2. So let's do a quick thing. 5 divided by what is 1? Hopefully you said 5. 12 divided by a number is 1. What did he say? Yes, 12. 12 divided by 12 is 1 whole. 3/5 divided by what is 1 whole? It is 3/5. When you divide a numerator and denominator when they are the same number, it represents 1 whole. What about 2 and 3/5 divided by what is 1 whole? Hopefully you said 2 and 3/5. If you do not trust me, get out a calculator and put 2.6 divided by 2.6. Will that equal 1 whole? It will. So what we are learning is something called complex fraction. A complex fraction is a fraction where the numerator and denominator are both contain a fraction. So as you notice in this problem, you see the fraction on the denominator, fraction in the numerator, fraction in the numerator and denominator. That's what makes it complex. So for example, a construction worker is blacktopping a driveway. She blacktops 35.5 square yards in 5-6 hours. How many square yards can she blacktop per hour? Each hour. For every 1 hour. So I've already set up the problem here. So I remember in rate, you got to label it. 35.5 for square yards. She did it in 5-6 hours. We would like to figure out how many square yards can she do in 1 hour, per hour, each hour. So to turn 5-6 to 1 hour, we divide the numerator and denominator by 5-6. Because 5-6 divided by 6 is 1 hour. Now we need to divide this. So what is 35.5? 30 divided by 5-6. Do you remember how to divide mixed numbers? Again, if you forgot how to divide mixed numbers, please go back to the previous videos on how to divide mixed numbers. So 35.5. Well, we can rewrite this as an improper fraction. This 35 times 2 is 70, plus 1 is 71/2. So we keep this. We multiply its reciprocal. To divide a fraction, in case you forgot, you multiply by its reciprocal. What is the reciprocal of 5/6? 6/5. So we multiply this. 71 times 6 is 426. 2 times 5 is 10. Let's simplify this. 5. Divide both numbers by 2. They are even. So that's 213 divided by 5. How many groups of 5 go into 213? I have no idea. So let's divide it and figure out. Can 5 go into 22? No. Can it go into 21? It goes in 4 times. Bring down the 1, bring down the 3. How many 5s go in 13? 2 times. Subtract that as 3. I need to get rid of this. How do I get rid of this decimal? Put up 0, bring it down. 0.0, bring it down. How many 5s go in 30? 6 times. So she can blacktop 42 6/10 square yards per hour. Each hour, 1 hour. Let's go back to here and rewrite it here. So she can do 42.6 square yards. If you would like to leave it in fractional, a mixed number form, it could be, let's go back here, 42 3/5, if that is what you prefer. 42 6/10, which simplified to 3/5. So that's how you solve complex fraction. Let's practice several more examples. Mr. Ito is spreading mulch in his yard. He spreads 4 2/3 square yards in 2 hours. How many square yards can he mulch per hour? So if you like the bar diagram, he has 4 2/3 square yards. That takes him 2 hours. But I want to find out how much mulch per hour. Each hour, 1 hour. So I need to split it into two groups, two equal groups. Or if you prefer, setting up as a rate, so 4 2/3 square yard, and it takes 2 hours, and I need to break it down to 1 hour, or each hour per hour. How will I break it down? I divide by 2, the numerator and denominator. So I need to divide by 2. So it's 4 2/3 divided by 2. Let's see, how do you divide mixed number? You multiply by its reciprocal. Can you rewrite 4 2/3 as an improper fraction? That's 12 plus 2. 4 times 3 is 12. Plus 2 is 14/3. So I keep it. I multiply. What's the reciprocal of 2? If I flip 2 around, well, first of all, I know 2 can be written as 2/1 as an improper fraction. If I flip it around, it'll be 1/2. That is the reciprocal of 2. So I multiply, I get 14/6. Can you simplify 14/6? Yes, you can. 7/3. Do you know another way to say 7/3? Can 3 go into 7? 2 times. That's 6. You have 1 left over. So the answer is 2 1/3 square feet for each hour per hour for 1 hour. So that's what Mr. Ito can do. Aubrey can walk 4.5 miles in 1.5 hours. Calculate her average speed in miles per hour. So we have 4.5 miles. Let's set up as a rate. 1.5 hours. Again, what is a rate? A rate is comparing two quantities with different units. So 4.5 miles in 1.5 hours. It said per hour. Each hour, 1 hour. So how do you break it down 1.5 hour to 1 hour? I have to divide by what? What do you divide 1.5 by to get 1? Divide the numerator and denominator by 1.5. Oh goodness, some of you say, oh, I forgot how to divide decimal. Again, look at my previous videos in case you forgot. But I'll just tell you right now, if you do not want to search my previous videos, set them in fraction form. 4.5 divided by 1.5. How can I turn this denominator into a whole number? 15. Some of you would say move the decimal 1 over, move the decimal 1 over, and that's what you do. But the mathematics is you're multiplying by the power of 10, you multiply the power by 10. So, oh, I know what's 45 divided by 15. That's just 3. So she can walk 3 miles in an hour. That's not bad. That's a pretty good walker. And next question. Mr. Joe's fan club members are making spirit buttons. Yes, I do have my own fan club. They made 490 spirit buttons in 3.5 hours. That's a lot of buttons in 3.5 hours. No, I am not a slave driver. So calculate the number of buttons the fan club members made per hour. And no students were hurt in the making of the spirit buttons. They were all volunteers. So, all right, so we need to calculate how many buttons they made per hour, each hour, or for 1 hour. So they made how many buttons again? 490 buttons. It took them 3.5 hours. Do you know another way to say 3.5 hours? Can you write that in decimal form? What about 3.5 hours? You can leave it in fraction form if that's what you prefer, but I'd rather use 3.5 hours. But it says how many buttons were made in per hour, each hour or 1 hour. So how do you turn 3.5 hours to 1 hour? By the way, that's a HR. How can I break it down from 3.5 hours to 1 hour? I will have to divide the numerator and denominator by 3.5. So 490 divided by 3.5. So, again, for those who forgot how to divide decimal, let's set up in fractional form. 490 divided by 3.5. I need to turn this denominator into a whole number. So I turn it to 35. Before you say, oh, you just do that, again, you multiply it by the power of 10. So if I multiply this by 10, then I multiply this by 10, that'll be 4,900. Some of you who like the shortcuts, you move this decimal one over. Where's the decimal point? Place right here. So you move this one over, put a placeholder there. That's where I got 4,900. So what is 4,900 divided by 35? Exciting. I'm curious how many buttons my fan club can make in an hour. So 4,900 divided by 35. Can 35 go into 4? 0 times. Can 35 go into 49? 1 time. So if I subtract 49 minus 35, I get 14. Don't forget to bring down that 0 right here. How many 35s go into 140? Let's see, 35, 70, 105, 140. That's 4 times. So that's 140. And this is where kids always mess up right here. They say, I'm done, 14. No. Do you remember the 0? You got to bring down that 0. This 0, bring it down. Can 35 go into this 0? 0 times. Make sure you put 0 here. So my fan club makes 140 buttons per hour. Each hour, 1 hour. That's a lot of buttons. But in 3.5 hours, I don't even give them a break, they can make 490 buttons. So our last activity is this. We have 4 families, the Pitts, the Starks, the Gilmores, and the Brown. They decided to go to South Padre, Texas for a relaxing vacation. They rented a house in South Padre to share for the week. Each family left the Pitts house at the same time, but travel at different speeds. If each family continues to drive at the same rate, in what order will they arrive in South Padre? The Starks drove 210 miles in 3 hours. The Pitts drove 306 miles in 4.5 hours. The Gilmores drove 305 miles in 5 hours. The Browns drove 99 miles in 1.5 hours. So I want to figure out their speed. So speed is mile per hour. So I need to do an apple-to-apple comparison. How many miles does each family drive in 1 hour? So let's start with the Starks. If you like the bar diagram, you can draw a bar. So we know is they drive 210 miles in 3 hours. So I need to break this down into 3 sections. Oh, so they can do, if I break it at 70 miles per hour. Shortcut is MPH, 70 miles per hour. 70 miles for each hour or 70 miles for every 1 hour. Now that is easy. Oh goodness, now this is where it gets a little harder. So you cannot really do a bar, you could kind of do a bar diagram here, but it's really, really difficult to see. So we're going to do a rate problem. So they can drive 306 miles in 4.5 hours. I'm going to use 4.5 hours. I'd rather work with decimals than fractions. So I need to break it down per hour for 1 hour each hour. So how do you break 4.5 to 1 hour? I divide by 4.5. So we have 360. We're dividing by 4.5. Again, for those who forgot how to divide by decimals, I do not like working with decimals when I divide. So I need to turn this 4.5 into a whole number. I move the decimal 1 over, That's 45. Again, mathematically, y, you're multiplying by the power of 10. So you multiply by 10, you get 45. I move this one over, put a placeholder here because I'm multiplying by the power of 10. That's 3,600. So how many 45s go into 3,600s? I don't know. Let's figure it out. So here's 3,600. I'm dividing by 45. Can 45 go into 3? 0 times. Can 45 go into 36? 0 times. Can 45 go into 360? I have no idea. 45, 90. I will say 8 if I had to estimate. Let's see. 5 times 8 is 40. Carry the 4. 4 times 8 is 32 plus 4 is 360. Hey, it works. Good guess. Good guess. 0. And I bring down this 0. Again, the answer is not 8. 45 times 8 is not 3,600. Can 45 go in 0? 0 times. Alright, they drive it way too fast because they drove, gosh, the Pitts family drove 80 miles in 1 hour. That's way too fast. And let's look at the Gilmore. So the Gilmore, do you want to do a bar diagram or you want to you could do a bar diagram. They drove 305 miles in 5 hours. So I need to break this down into 5 sections. So how many miles go for each hour? So let's divide this. So 305 divided by 5. Can 5 go in 3? 0 times. Can 5 go in 30? 6 times. Can 5 go in 5? 1 time. So they drove 61 miles per hour. 61 mph, miles per hour. So far, wait. So let's see. Pitt's fastest, 80 miles per hour. Then Stark's family, 70 miles per hour. Then Gilmore, 61 miles per hour. And last family, the Browns family drove 99 miles in 1.5 hours. So let's set up as a rate problem. So we have 99 miles, and that takes them 1.5 hours. Do you want to leave it in a fractional form or you want to work with decimals? I prefer working with decimals, so I'm going to turn it to 1.5 hours. So it says how far did they travel in 1 hour, per hour, each hour. So how do I break it down from 1.5 hours to 1 hour? I am going to divide by 1.5. So let's divide this. So it's 99 divided by 1.5. Again, when I divide decimals, I do not like working with decimals. So I multiply the numerator denominator by the power of 10 to get rid of this decimal, which will be 15. Some of you will just say, can I just move the decimal 1 over? Okay, yeah, that works. Move the decimal 1 over, so that's 990. So what is 990 divided by 15? So let's figure out. I honestly don't know. So we're going to figure out 990 divided by 15. How many 15s go in 9? 0 times. How many 15s go into 99? 15, 30, 45, 60, 75, 90. 6 times. That's 90. So they are one of the slower family. So that's 9. Bring down to 0. So how many 15s go in 90? 6 times again. So they drove 66 miles per hour. So what is the answer? So it said put them in order. So Stark's family was 70. The Pitts family was 80. The Gilmore family was 61 miles per hour. And Brown family, was it 66? Let's go back. Brown was 60. Yes, it was 66 miles per hour. So it said, in what order will they arrive? So they left the Pitts house at the same time, but travel at different speeds. Who will get there? So Pitt's family will be first, then Starks, then Brown, then the Gilmores. And this is complex fraction. So again, complex fraction is dividing when you have a fraction inside of another fraction, and you have to break it down by dividing.